What's coming off around here?
If you guys playing railroad anymore today, there's a landslide, a new cut.
Okay, well, I got the NCE USB interface board, and as you can see it, this interface module, it arrived in a small cardboard box in a little plastic bag with this instruction information was stapled to the bag to keep the bag shut. I guess it was adequate, but I would have preferred to see it in an anti-static bag rather than just a plastic bag, because plastic bags can tend to develop a lot of electrostatic discharge. Well, the electrostatic part of it, you don't want it to discharge because it'll damage the circuits. But anyway, it seems to be in order. I don't see any. I inspected it carefully and I didn't see any bad solder joints or anything. So the quality of the assembly looks like it was pretty good. From a high-level view regarding the serial I/O that's taking place, the ideal communication path is going to be from the PC running JMRI through the Bluetooth I/O where that was set up as a COM port for the JMRI. To the Bluetooth module that's attached to the Arduino. That bidirectional communication is then passed by the Arduino through its USB port using a male-to-male cable. And the reason for the male-to-male cable is that both the NCE USB interface board and the Arduino have female connectors. So this may or may not be allowable. I might need to get it. I might need to modify it to become a crossover cable. I'm not yet sure about that. But it has two signals that the USB uses. It's a D plus and a D minus differential signal. It might be an essential part of that signal's electronics that these must match correctly. So we'll find out more about that. But anyway, the USB from the USB interface, the NCE's device, has an RJ11 connector which goes through the cab bus cable, that which is then tied to the power cab, and also the power from the wall wart powering both the power cab and the converter is routed back through the same cable and it powers up the USB interface board. So in a nutshell, there's two issues that have to be considered. The first is this issue about the differential signal wiring. Do I need to modify this cable to become a crossover cable to make sure that the two signals from the two different devices are matching up? And the other thing I have to consider is that these are both USB devices. They're both actually what's sometimes called slave devices, or they just call them a device. But thing is, when a USB device is plugged into like a PC, where we'd be over here, the PC is configured on its USB port to become a master, which is often used term in the USBs, that it's a controller. And the reason for that is that the cable signal lines, the D plus and D minus, is a differential signal, and it can be in one direction or the other direction, but it's not bidirectional, purely bidirectional. There has to be something controlling when this device can put its data onto the bus, and it's usually done by some control. So my speculation, again, here's another issue that has to be looked at, is whether I can create software on the Arduino that's going to act like a master and be able to control this device. And we're going to see. That's another thing that will be looked at in the future. It's like right here on the board, I noticed that it has a PIC 16 microcontroller from Microchip Technologies. Microchip is, they offer a library that's called the USB stack, so I suspect that they used this PIC in order to implement the actual communications part, the protocol of the USB communications here. But I noticed also that the USB is routed through this chip right here, which is it's a CH340 340N actually, integrated circuit or IC. The chip converts the USB electrical signal to a serial modem type control, a serial control like you would expect for microcontroller to be able to handle the receive and transmit data, which in fact does. You see the signal, I'll have to give you a close-up here, but the signal actually goes from the USB to serial converter directly to the pins, which are, it's 17s to transmit and 18, I can count correctly. Anyway, that's the PIC serial I/O, which would be communicating to and fro from the USB interface. The RJ11 connector over here, which goes over to the cab control, Power Cab interface connectors. That would be this guy right here, and you know, obviously it's going to be plugged into the extra cab part of that. They have, like on here, what you see down here, there's a chip, pardon me, and that's a half duplex RS-485 transceiver chip. So in fact, this is a 485 network that I've been looking at, which I was pretty confident of it anyway, but you know, it's nice to see an actual bit of evidence that it is in fact. One thing that I have to look into first is how the serial information is handled electronically on the USB interface board. This diagram that I have currently is depicting the USB data handling, and I'm going to take and study that a little bit for this discussion. The serial I/O that's taking place between the information that the PIC 16 has and the USB or on the Arduino side, and this is the PIC 16 that's on this board, the converter board, or what they call the USB interface. That communication goes through a USB controller chip called a CH340D. And on the PIC 16 side, it's simply a serial I/O, and that is controlled by the PICs, pins 17 and 18, which are the transmit and receive, that go to the PIC 16's UART chip, or chip. It's UART module, and that goes to the RXD and TXD of the converter chip, and then that in turn converts it's a bidirectional transfer of information, so the transmit and receive are both being converted to this differential signal that is used by the USB. And so on the USB, D minus and D plus are differential signals created by this, and also created by the on the Arduino side. So there's both transmit and receive taking place. The other side of the serial data transfer is via the RJ11 connector to and from the cab bus. I show it over here. Here's a cab bus coming into the RJ11. The cab bus 45 signal is received on the USB interface board through its RJ11 connector as a differential signal. This is the same signal I displayed on the oscilloscope in the previous episode. On the USB interface board, the differential signal is routed to the SP45 differential signal transceiver chip, which is this little chip right here with the big name. When the signal is being received from the cab bus, the PIC16 enables it by applying a logic low level on the RE input to this chip. So we show the chip here, and here's the RE level right there. When transmitting onto the cab bus's 485 signal, the PIC16 applies a logic high level on the 485C's DE input, this one right here. This switching is accomplished with a single PIC16 output that is high to transmit and mostly low to receive. This signal right here. I say mostly low because the USB interface board is addressable on the cab bus. Its address is set using the jumpers on the board down here. So the code from the USB converter only ever transmits to the cab bus via the SP45 if it receives its address from the power cab and it has data from the USB interface that needs to be passed along. Because data is either transmitted or received on the cab bus, the same signal is used on the PIC16 for both. This signal right here, serial AO. Up here in the top is a chip which is an IC for voltage regulation. That chip that they have there, it's an L78 voltage regulator. It seems that the main voltage for the regulator comes from the RJ11 DC pair, the DC power pair. That's routed on the back of the board up to this chip. And then this chip regulates that to produce the voltages necessary for all the rest of it. And although the USB interface does have, like most USB interfaces do have some power to them, they're not using it at all. It's all, this everything is powered from the RJ11 connector back up to the power supply through this guy. The instruction sheet talks about the interface, that it comes with opto isolation right here, opto isolated USB. And the best I could figure from observing what this chip is, that's not opto isolated. And there's no other means of opto isolation like an opto isolator chip on here at all. So I'm going to conclude, at least to my best guess, that there isn't any opto isolation at all. And I think that because the power is the same power that the power cab has, it's the power that's powering the board. The only thing connecting this whole arrangement to a PC, for instance, is through the USB interface. And I imagine the PC would have some opto isolation to protect it. So that's about the only protection that I think this whole thing gets. I think that just about covers everything here. But what's interesting is, as I pointed out already, is that all of the power is common. The power that powers up all of this is common to all of the power that's routed through the four connectors on this interface that come in the barrel connector from the power supply, the wall wart. And that's the same that powers up the power cab. So there's all of that. More about powering the USB interface module. All of the chips receive a 5-volt source that is plus 5 volts with respect to some neutral or what I call 5 volts minus. That is generated by this voltage regulator chip that the 78L05 gets its actual power input from the cab bus through the RJ11 connector, pins 2 and 3, the black and red leads that are coming from the cab bus. Then connect to the input side of the 78L05. So you have, pardon me, 13.8 volts with respect to neutral coming from the RJ11 connector. And then on the output, it has a 5 volt signal that's going to all of the chips on the board. And so when the power cab is receiving power, also everything, recall through this device, everything is getting power via the 13.8 volts that comes from the wall wart that gets plugged in, the power supply. So this power is then regulated to 5 volts. But it's interesting because the way this chip works is that this 5 volts is with respect to some V minus, which is actually derived from the USB connectors V minus. That's the negative side, or what we might call ground in this case. But it's not earth ground, but it's the neutral used by the USB, which in this case would be the Arduino power supply, which is a separate power supply from the one powering up the cab bus. So that's an interesting solution to provide 5 volts to the chips on the converter. That's with respect to the USB neutral rather than the RJ11 cab bus neutral. Not sure what exactly that implication is yet, and I have to give that a little more thought, but it seems to me very safe. I don't feel that it would in any way danger the either the converter board or the power cab electronics by doing this. I think that is perfectly safe to do that. What I mean is perfectly safe to use a separate power source that's tied to this Arduino. So I'll be careful about that though and take some measurements before I actually connect them. Well, I've had about enough with analysis. I think it's time that I move on to actually doing some experiments, actually seeing some real data and finding out what my capabilities are. Do I need to modify this cable to be a crossover? Will the USB connection work if I modify software on the Arduino, since this is a slave USB stack? Will the power be safe? Can I connect the power without having concerns that the Arduino has a separate power supply? A lot of questions yet. So, we'll find out in the upcoming episodes of this exciting investigation into whether I can run JMRI, I said it right that time, on my broken PC. Well, we'll see. I would like to ask anyone who has actually suffered through this video, all the details and analysis, if any of it was interesting to you, or if any of it you liked, or if you have any comments about what the content is or questions, please feel free to respond and leave a like. If you didn't like it, then that's just fine. But if you wouldn't mind leaving me a note as to what I could do to improve it and maybe make it a little bit more meaningful for you. Thanks a lot. See you in the next episode.